5 is on polynomial and sinusoidal functions. So the first half of the chapter we'll be looking at polynomial functions, and the second half we'll be looking at sinusoidal. Polynomial functions are things you've looked at before, and today we'll be looking at polynomial functions of degrees 0, 1, and 2. And to tell the truth, this is really entirely review from previous courses, math courses, but there's a lot to know here, so we'll spend some time and go over it all. So the first thing we need to know is, what is a polynomial function? And what a polynomial function is, it's one or more terms that are separated by plus or minus signs. And all the coefficients are real numbers and all the exponents are whole numbers. So coefficients, I guess we could define it right now. Coefficients are a number that multiplies a variable. And all exponents are whole numbers. Okay, so let's write down an example of a couple of these. I'm not sure if I'm going to squish them in. Why don't I squish them in over here? So here is a polynomial right there. That's a monomial, right? Now, if you want it to be a polynomial function, let's just say f of x equals 5x squared, and that's a polynomial function. It's a monomial. Let's do a binomial. That's another type of polynomial function. How about 2x cubed minus 8? That's a polynomial function. It's a binomial. See how there's a minus to separate things? Let's do a trinomial. H of x equals 5xy plus 2x squared minus y or something. Okay, you got three terms, each they're separated by plus or minus signs. All the coefficients, remember coefficients are the numbers up front, like the 5, the 2, the 5, the 2 here, they're all real numbers. So they could be negative, they can be fractions, they can be decimals, and they can even be irrational. So it could be, you could have square root of 2 up front, that's fine. And all the exponents are whole numbers. So the exponent here cannot be negative. If you put negative here, it's no longer a polynomial function. And they cannot be decimals. If you put 3.3 here for raising x to the 3.3 or something, then it's no longer a polynomial function. Anyway, you don't have to worry about this too much, but there's a quick review of that kind of stuff. So degree, to get the degree, maybe I'll just eliminate those errors I made there. To get the degree, what you do is you take a look at the value of the highest exponent. So in the monomial here, the biggest exponent I see is 2, so the degree is 2. In the binomial, the biggest exponent I see is a 3, so the degree is 3. In this one, it's a little tricky. You won't have to worry about this in this chapter's work. But if you have 5xy, that means there's a 1 here, and there's also a 1 there. So the degree of the first term is 2. The degree of this, I don't even know what number I said that was. I think it's a 2. So the degree of the second term is 2. The degree of the third term is 1. So which one's the biggest here? You don't add them together, you just pick the biggest. Well, the biggest is 2. So the degree of this would be 2. Don't get confused by that. Let's do a different example, which I'll use for all the rest of these. So let's make our example 3x squared plus x cubed minus 4x minus 2. And we want to know what the degree of that is. So again, you just look to see what the highest exponent is. The highest exponent I see is 3, so the degree is 3. Great. Constant, or constant term, is the term with no variable. So in this case, here, the purple example here, what's the constant? Are you saying 2? Well, you're wrong. It's not 2, it's negative 2. You always take the sign in front of it. So negative 2 is the constant. Coefficient, a number that multiplies a variable. So again, if we look back here at the purple example, what are our coefficients? 3 is a coefficient. What multiplies the variable here? 1. So 1's a coefficient. What multiplies the x? Negative 4. Some books are, grade 10 book considered negative 2 a coefficient. I don't like that. The reason you can consider a coefficient is because you could consider this as multiplying x to the 0 power, but I prefer to think of negative 2 as the constant and not as a constant and a coefficient. The leading coefficient. The leading coefficient is the number that multiplies the term with the highest power. So when you see leading, often you think it's the first one, but in this case it's not. The leading coefficient in this case is 1. How come? Because the highest power is 3 and the coefficient in front of it is 1. Now, why is it called a leading coefficient? Because if you write these in descending order, it will be the first coefficient. What I mean by descending order is usually you wouldn't write this polynomial this way. First of all, you'd put the x cubed, so you'd have x cubed. Then you put the x squared, so you'd have plus 3x squared. Then you'd put the x, so you have minus 4x. And then you'd put the constant, minus 2. And in that case, the leading coefficient is at the front, and the leading coefficient right there is 1. Okay? All right, so moving on. Polynomial functions of degree 0 we're going to do today, degree 1, and degree 2. So first one, we have the function f of x equals 4. This is degree 0, right? There is no exponent here. If you were going to put a variable, you'd have to put x to the 0, because x to the 0 equals 1, and 4 times 1 is 4. So this is definitely degree 0. And if you were going to graph that, do you know what it looks like if it's f of x equals 4? Remember, f of x is kind of the same as y. So if you're graphing y equals 4, what do? You look for all the points that have a y value 4. Like this point has a y value 4, that's 0, 4. But so does this, that's 1, 4. This is 2, 4. This is 2.54. This is negative 5, 4. And if you do all of them, you're going to end up with a straight line right here. So we'll put some arrows on that, and that is f of x equals 4. Maybe we'll do it in red so we can distinguish it. Good. G of x equals negative 1.5. Very similar. Let's do this one in green. Where does y, because that's what g of x really is, where does y equal negative 1.5? Negative 1.5. There's negative 1.5. So is here, so is here, so is here, so is here, here, all those spots. So we can draw a line right there. Put arrows on that, and we're finished. Okay, so you get the idea. If you do a polynomial function of degree 0, if you graph it, what are you always going to get? You're going to get a horizontal line. What's the slope of that line? Do you remember what the slope is of a horizontal line? Well, you can turn a horizontal line into a z for 0. So the slope is 0. What's the domain? Goes forever in the left, goes forever in the right. That means the domain is x is an element of all real numbers, or from negative infinity to infinity. What's the range? Well, let's take a look at this red one first. What's the range of that line? What's the only y value that there is? Just 4. What's the range of the green one? What's the only y value there is of all these points? Negative 1.5. Oh, so it looks like the range is always equal to the constant, right? If it was g of x equals 7, the constant is 7, so the range would also be y equals 7. Hope that makes sense. X-intercept. Is there any x-intercept here? No. Is there any x-intercept here? No. So you'd say none, but there is an exception. When are you going to have an exception? When would there be an x-intercept? You'd have an x-intercept if you had something like f of x or y equals 0. Because if you had f of x equals 0, it would be right along here. What's the x-intercept? The x-intercept is all real numbers. Everything's an x-intercept. And the y-intercept. Well, the y-intercept in this question here is 4, and the y-intercept in this one is negative 1.5, and the y-intercept in this one is 0. Again, that's just the same as the constant. So the y-intercept is the value of the constant. And maybe for the range, I should have also said value of the constant. The end behavior. Okay, remember those are the quadrants you end up in. The red line goes from quadrant 2 to 1. The green one goes from quadrant 3 to 4. And those are kind of your two options, except again for this exception one, this one doesn't really go in any quadrants. We don't consider the x-axis a quadrant. So, but we're gonna keep this as our end behavior, either from 2 to 1 or from 3 to 4. Okay, and that's it. That's the main things you need to know about polynomial functions of degree 0. Let's move on to polynomial functions of degree 1. So that's things like this. H of x equals 2x minus 4. Remember, this is 2x to the first power. The highest exponent is 1, so this has degree 1. We're going to graph that. What does that look like? If I switch that into y equals 2x minus 4, I'm hoping you recognize that. We did a whole bunch of stuff in this in grade 10 and last year too. This is slope-intercept form. -4. So I put a dot there. What's the slope? 2 or 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, do it as many times as you want, and now I can draw a line. And we're done that one. So for the next one, again, if it's y equals -1/2 x, what's the y-intercept? Well, I don't see one there. It's kind of because it's plus 0. So the y-intercept is 0. And our slope is -1 over 2. That means down 1, because -1, down 1 over 2, down 1 over 2, down 1 over 2. Or if you want, up 1, which is a positive move, and -2, so to the left 2. That's a negative move. Positive move up, negative move left. And there you go. You have your points. You can draw your line. Again, I'm going pretty fast here because this is review. If you need extra help with this, let me know. And highlight this. So what are we looking at here when we have polynomial functions of degree 1? Basically, what we end up with is a line of the form y equals mx plus b. And you know some stuff about y equals mx plus b. What's the slope of a line y equals mx plus b? The slope is m. What's the domain of both of these lines? Well, it goes forever and ever to the left, forever and ever to the right. So again, we have x as an element of all real numbers, or from -infinity to infinity. What's the range? It goes down forever, it goes up forever. It goes down forever, it goes up forever. Oh, the range is also an element of all real numbers, -infinity to infinity. How about the x-intercept? Well, it changes what the x-intercept is, but how many x-intercepts will there be? No matter where you draw the lines, since we're not including horizontal lines, and we're also not including vertical lines, I'll talk about that in a second, why, but if we don't include horizontal lines and vertical lines, how many x-intercepts will there always be? There'll always just be 1. How about y-intercepts? How many will be? There'll always be 1, again, and where will it be? It will be at b. That's what b stands for in the y equals mx plus b. And the end behavior. Okay, well, there's actually two options here. If you have the lines like the purple one here with a positive slope, right? This is a positive slope line. Then it goes from quadrant 3 to 1, or 1 to 3. And if you have a negatively sloped line, right? The blue one here is negatively sloped. It's going to go from 2 to 4, quadrant 2 to 4. Now, one last thing. I said I would explain why are we not dealing with vertical lines when it was degree 0 or degree 1. And the reason for that is because of this word right here. We're only talking about functions today. Is that a function? No, it's not. How come? Because it fails the vertical line test. If you draw a vertical line here, how many times does it go through the red line? It goes through an infinite number of times. That doesn't work. But if you slide that vertical line along the blue line, there's never a case where it crosses, where the blue line crosses it twice. So the blue line is a function. Same with the purple one. It is a function. It never crosses in two places. But with the red one, a vertical line, not a function. That's why we're not considering the vertical lines. Okay, we're on to the last one. Polynomial functions of degree 2. I had made a mistake. I think I have it corrected on your paper. Okay, this we did a bunch of last year, so hopefully this looks somewhat familiar. If you have an x squared term, you're not going to get a line, you're going to get a parabola. The ones we're about to do now, you should get parabolas. So in the first one, this is actually in standard form. I don't know if you remember that from last year, but you should be able to tell me the vertex right now. The vertex is 0, 4. If you don't remember this, I don't think it's a big deal for now, but maybe we'll talk about it in class. And let's just do the step pattern. This is a negative here. Do you remember what that means? It means it faces downwards. And the step pattern means over 1, down 1, over 1, down 3, 1, 2, 3, over 1, down 5, 1, 2, 3, 4, 5, and then over 1, down 7, but that won't fit. And then because of symmetry, we have a point there, we have a point there, we have a point there, and we can draw a parabola, which I always struggle with. Not bad. And okay. Okay, the next one's not in standard form, unfortunately, so you could use negative b over 2a to figure this out. Or the other way you could do this is you could actually factor this. We didn't do this very much last year, but let's try factoring this. We're looking for two numbers that multiply to 5 and subtract to 4. So first of all, x and x. Two numbers that multiply to 5 and subtract to 4, 5 and 1. Put the big one in the first one, small one in the second one, drag down this sign. A positive times a what equals a negative, a positive times a negative. So now that I have that q of x is equal to this, what are these telling me here? This helps me figure out what the zeros are, or if you want, the x-intercepts. The zeros, or the x-intercepts, are equal to, what would make the first bracket 0? If x was negative 5. What would make the second bracket 0? If x was 1. So these are my zeros, or my x-intercepts, negative 5 and 1. Now, because of symmetry, where must the vertex be at? The vertex has to be right in the middle of those. Well, right in the middle, 1, 2, 3, 4, 5, 6. It's 6 steps. Go 3 steps. 1, 2, 3. So the axis of symmetry, remember there's an axis of symmetry, an imaginary line that goes right through the vertex. The axis of symmetry has to be right here. The value of the vertex has to be negative 2, comma something. How do we get the something? You put negative 2 into these spots here and here. So you get negative 2 squared, which is 4. 4 times negative 2 is negative 8. Then take away another 5. 4 take away 8 is negative 4. Take away 5 is negative 9. So negative 2, negative 9 is your vertex. That's way down here. And the a value is 1. So that means it faces up, and we just follow the same step pattern. Over 1 up 1, over 1 up 3, 1, 2, 3, over 1 up 5, over 1, notice it goes right to the point we'd already figured out, over 1 up 7, so like that. And because of symmetry, here, 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 and here, and there we go. Now, if your head's spinning a little bit with all that, like, wow, we went through that so fast, and there was so much stuff, axis of symmetry, and all that kind of stuff, don't worry. I believe they'll just give you the parabolas in all the cases, so you don't really have to worry about it. Still, it's stuff we have done before, so hopefully it at least looks familiar. Okay, let's finish this off. The domain. So if you look at the x values of these parabolas, it goes forever and ever out to the left, forever and ever out to the right. So it is x is an element of all reals, or negative infinity to infinity. Remember, just like last year, we're not going to look at parabolas like this, and we're not going to look like parabolas like that. How come? Again, because we're looking at functions. These both fail the vertical lines test. Crosses it in 2 spots. The range. Okay, well, it depends. If it's the red parabola, then all your y values are greater than some amount. What amount? The y value of the vertex. So y is greater than the y value, it's a bit confusing, y is greater or equal to, sorry, than the y value of the vertex. So that's when the parabola faces up. If the parabola faces down, like the purple one here, then all the y values are less than or equal to the y value of the vertex. The x-intercept. Again, we can't really say exactly what the x-intercept is. We can mention how many x-intercepts there can be. How many x-intercepts do I have in both of these cases? 2. 1, 2, 1, 2. Is that the only possibility? No, you can have one x-intercept. If the vertex was right on the x-axis, and whether it faces up or if it faces down, it doesn't matter, you have one x-intercept. Is it possible to have no x-intercepts? Yeah, that's possible too. If it's up here and faces up, whoops, or if it's down here and faces down, you have none. So you can have 0, 1, or 2 of them. Y-intercept? There will always be one. Even if I have a parabola here and you're like, that doesn't cross the y-intercept, this gets wider and wider and wider and wider, and somewhere way up there it will cross. So always one of them. And if it's written in either of these forms, because this one's written in standard and general form, and this one's written in general form. So if it's written in the form y equals ax squared plus bx plus c, then the y-intercept is at c, as long as it's written in that form. The end behavior. Well, if the red one, it's going to go from 1 to 2. And with the purple parabola, it comes down from quadrants 3 to quadrant 4. Okay, and that'll be same for all parabolas. It'll be one of these cases. Even the blue one, for example, here, this will go wider and wider and wider and eventually end up in quadrant 2. This will come up and up and up and eventually end up in quadrant 1. Last thing, the turning point. So the turning point refers to where the parabola changes direction, right? If you look at the red one, it's coming down, 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 down. Oh, there's the turning point right there. So the turning point's the vertex, and we have a name for the vertex in these cases. In this case, if it's down low here, it's called a minimum. So you get a minimum if the parabola is obviously facing up like this, or if the a value is positive, and you get a maximum if the parabola is facing downwards like this, and that happens when the a value is negative. Alright, there you go. We've summarized everything. So next day we're going to do polynomial functions of degree 3, which will actually be new stuff. Degree 3 are called cubic functions. Degree 2, which we just did today, you know this, it's called quadratic functions. Degree 1, which we also did today, are called linear functions. And degree 0, which we did today, are called constant functions. Okay, see you next time.